So now we are going to start a mock interview for our student Ratesh, and this interview is for PhD admissions.
Yes.
Ratesh, first of all, you introduce yourself.
Yes, sir. Good afternoon to all. I am Ratnesh Kumar from Sasaram, Bihar. I completed my bachelor degree from RGPB University Bhopal in civil engineering with 85.9% and master degree from NIT Jamshedpur in structural engineering with 9.5 CGPA. I have been awarded by Chancellor Scholarship by RGPB University Bhopal in UG and won gold medal for higher academic performance in PG.
So why do you want to join for PhD now?
Sir, I want to join PhD for, I want to take my career in the field of research and teaching field. So I want to join this PhD.
So have you identified any particular area to work?
Yes, sir. I want in the work of structural dynamics in the field of earthquake and blast loading.
Okay, so why is this topic important for you?
Sir, in the M.Tech, I work on this. In the M.Tech thesis, I work in this topic in the field of structural dynamics. So after this work, I interest in the field of this topic, and so I work in this.
Okay. So और कहाँ अप्लाई किया आपने? अदर IITs में भी अप्लाई किया है कहीं पे?
Yes, sir. I apply for IIT Delhi, IIT Madras, IIT Patna.
So कहाँ पे ज्वाइन करोगे अगर सभी जगह एडमिशन मिल जाता है तब?
Sir, I see according to my topic which professor is interested me and which IIT is the best for me. So,
Okay. और बीच में छोड़ोगे तो नहीं, ड्रॉप तो नहीं करोगे?
No, sir. I
कहीं PSU की तैयारी कर रहे हो क्या साथ में कुछ?
No, sir. I only prepare for PhD.
Okay. मैथमेटिक्स में क्या क्या इंफॉर्मेशन है तुम्हें, क्या क्या नॉलेज है मैथमेटिक्स में, बताइए.
In mathematics, I study about linear algebra and calculus and numerical method.
तो रैंक कंप्यूट कर सकते हो किसी मैट्रिक्स का रैंक?
Yes, sir.
क्या होता है रैंक?
If any matrix is converted in the echelon form, then non-zero row is called the rank of the matrix.
ये एक मैट्रिक्स है.
Yes.
इसकी रैंक क्या होगी? देख के बता सकते हो ऐसे बिना कैलकुलेट करे सीधा? अच्छा चलो ये बताओ, एक x dy प्लस y dx इक्वल टू 0, ये एक डिफरेंशियल इक्वेशन है.
Yes, sir.
ये किस फैमिली को रिप्रेजेंट कर रही है? फैमिली ऑफ कर्व्स आइडेंटिफाई करो.
X dy y dx equal to g. Circle, sir.
Circle.
Yes, sir.
Okay. Okay, Bikram sir.
Okay, thank you, sir. Yeah, Arun sir.
हाँ जी सर, मैं ले रहा हूँ.
Oh, yes, over to you first.
Okay, okay, okay. Hello,
Yes, sir.
Ratish, am I audible to you?
Yes, sir.
Okay, तो हम लोगों ने शायद पहले भी किया है.
Yes, sir, yes.
बस snap interview है ना? Okay,
Yes,
so let's
sir.
start. So your masters in structural field, na? Structural.
Yes, yes, sir.
Okay,
Yes,
structural
sir.
engineering. Okay. So can you tell me कि अगर हम structural indeterminacy निकालते हैं, when we find the structural indeterminacy for
Yes, sir.
frames, तो
Yes,
उसके
sir.
लिए formula क्या रहता है?
Structure 3m plus r minus 3j plus
Okay.
number of hinge provided any other things.
ठीक है, मतलब मुझे बस ये था कि okay, 3m plus r minus 3j plus n.
Yes.
Okay.
Yes, sir.
Trusses के लिए इन्हीं terms में formula क्या होगा?
m plus r minus 2j.
अब बताओ डिफरेंस क्यों है दोनों फॉर्मूलाज में? उसमें 3m है, इसमें m क्यों है, 3j है, इसमें 2j क्यों है? ये बता सकते हो?
Yes, sir. In the case of frame, in a member come 3 reaction. एक horizontal force, एक vertical reaction, and एक moment. But in the case of truss is the axial member. In the truss केवल come axial and means tension and compression, and not come any moment. So in this case of a moment is equation is 0. So m plus r minus 2j we take it. In the case of frame, 3 equation, 3m plus r minus 2j main difference.
Okay, that 3m and m I understand, but why 3j and 2j?
2j minus r.
3m plus r minus 3j for frames ना, and then
Yes,
m
sir.
plus r minus 2j for truss. तो वो why there is 3j in case of frames, why 2j in case of trusses? That you
Yes,
have to tell.
sir. In the at the joint in the frame, take a sum of horizontal equal to 0, sum of vertical 0, and sum of moment 0. We take 3 equation. But in the case of truss, moment is 0. So we only take 2 equilibrium equations, sum of horizontal 0 and sum of vertical 0. So we take 2j.
Okay, correct. Okay, can you tell me the relationship between modulus of elasticity and modulus of rigidity? Shear modulus of rigidity.
Yes, modulus of elasticity.
Modulus of elasticity that we have.
Shear
Young's
modulus
modulus of elasticity.
Yes.
And modulus of rigidity.
Yes, modulus of elasticity is the ratio of normal stress by normal strain, and shear modulus of rigidity ratio of shear stress by shear strain.
So what is the relationship between both these moduli?
Yes, sir. E equal to 2g in E equal to 2g into 1 minus mu.
1 minus mu.
E equal to 2g into 1 plus mu equal to 1 plus mu, sir. 1 plus mu.
Okay. Do you know about this 3-moment equation?
3-moment, yes.
Also called Clapeyron theorem.
Yes, sir. 3-moment method, we find the moment in the indeterminate structure.
Okay. So can you tell me the generalized equation of that particular method that we use to find the moment in case of at joints in case of indeterminate structures?
Yes, sir.
Generalized equation you have to tell.
Yes, sir. MA ये generally sir take in the two frame. So MA equal to L1 by 1 I1 plus M2 MB into L1 by I1 plus L2 by I2 plus MC into L2 by I2 equal to 6A1 by A2 6A1A2 by L1 by I1 minus plus 6 minus 6A2 A2 by L1 by minus 6 A del relation between delta is why I miss this last
ये ठीक है starting जो था initial portion was correct but
Yes,
then there is some confusion तो
Yes,
ये एक
sir.
बार दोबारा से आप check करिए.
yes, yes, sir.
Okay, so in the initial beginning, when you were explaining about this three moment equation, you said it is used when there are two spans.
Yes,
Okay, you said no, this equation, this method is used when there are two spans.
yes, yes.
So what if I have an indeterminate structure? Suppose I have a propped cantilever. It
Yes,
has only
sir.
one span. So
Yes, sir.
उस केस में हम लोग कैसे इसको अप्लाई करेंगे three moment equation?
Sir, in the case of this frame, we take one span of the zero length
Okay,
and analysis this frame.
one span of zero imaginary length.
Yes, sir. Imaginary means imaginary zero
Okay.
length.
ठीक है. Can you tell me the Euler's buckling load for a column?
Yes, sir. Euler buckling load.
What is the formula for that?
Yes, sir. Formula for Euler buckling load pi square EI by L effective square.
L effective span. Okay. So this L effective will depend upon what? What are the factors on which this?
Yes, sir. L effective mainly depend on the fixed condition of column.
Fixed condition of the column.
Yes, sir.
Okay. Can you give an example, like how it will vary for various conditions?
Yes, sir. In the case of as like we take any beam, a column, if both in fixed, then effective length is L by 2. Both in the hinge, then effective length equal to L, and one in the hinge and one in the fixed, then effective length take L by √2, and one in fixed and one in free, then effective length take 2L.
Okay. ठीक है. अच्छा, can you tell me the difference between column and strut?
Yes, both are axial member, but column is the vertical member, but strut is the inclined member also.
Okay.
Means
Okay. Like
column is also straight strut,
as
but
in case
strut,
of a truss, we can say the inclined compression member can be called as a truss,
Yes,
but
yes.
they cannot be called as columns.
okay.
Achha, I'll give you a statement. You have to tell me this statement pertains to which law or which theorem. The partial derivative of strain energy with respect to load at a point is equal to the deflection at that point.
Yes, sir. Castellano first theorem, sir.
Are you sure? The partial derivative of strain energy with respect to load at a point is equal to deflection at that point.
Deflection.
Okay, chalo koi nahi.
Yes, sir. Castellano theorem.
Okay, your answer is Castigliano's first law. Okay. ठीक है. Last question I'll ask you. if I have a simply supported beam, for example, or say, let's say, and I apply a movement in between at the midpoint.
Yes, sir.
M a movement at the midpoint. Total
Yes.
length of the simply supported beam is L only.
Yes, sir.
Okay. Then what
Yes.
will be the deflection at center?
Deflection at center.
Yes.
Hmm. Sir, I'm not clear, but according to me, deflection at point is
Deflection at point.
I not I study, but I not clearly.
Okay. So Ratnesh, let me give you feedback.
Yes.
So whatever I asked and whatever you have answered, from here I can say that there is a vast improvement from the last time. ठीक है, जब हमने last time interact किया था, उसके मुकाबले मुझे काफी improvement लगी, especially beginning में, कि you were more confident और concepts मुझे ऐसा लगा कि आप मतलब आपने revision काफी अच्छा किया है. मैंने आपको advice किया था revise करने के लिए और आपने किया हुआ है. और ये चीज मुझे बहुत अच्छी लगी. दूसरा ये है कि आपके कॉन्सेप्ट अच्छे क्लियर हैं, काफी चीजें जो है वो आपको पता है. थोड़ा सा जैसे एक क्वेश्चन था वो अबाउट द 3 मोमेंट क्लेप्रॉन इक्वेशन, वो थोड़ा सा एक बार दोबारा से उसको लिख कर प्रैक्टिस कर लीजिएगा, बिकॉज कैन बी चांसेस कि वो भूल जाए, वो थोड़ा सा लंबा इक्वेशन है. इसके अलावा बाकी एक चीज और जो थी जो मैंने आपसे पूछा था कि पार्शियल डेरिवेटिव ऑफ दैट इज कास्टिग्लिआनो सेकंड थर्ड.
Yes, yes, I confused about
है ना, बिकॉज जब डिफ्लेक्शन निकाली है दैट इज सेकंड थ्योरम. Okay. If you want to find the redundant force, that is first theorem.
First one, yes, sir.
Partial derivative with respect to deflection, that is first
Yes,
theorem.
sir. Yes.
And last question जो मैंने आपको दिया था उसका आंसर is there will be no deflection at the center.
Yes, sir. I think that is not deflection because at this point we like at moment it is only rotation come on this point.
Only rotation will come over
in
there.
mind come that it no deflection. I want to say,
only,
but
only rotation of ml upon 12 vi
yes,
will come at the center.
I think this, but
yeah, it was a trick question. It was a trick question. So
yes,
yeah, it can happen. So नहीं, बाकी आपकी मुझे ओवरऑल आपका जो परफॉर्मेंस था वो अच्छा लगा. आपका इंटरव्यू कब है? कुछ आपका डेटा है?
26 नवंबर.
26 नवंबर. कौन से इंस्टीट्यूट के लिए आप कर रहे हो अप्लाई?
ये IIT हैदराबाद के लिए सर.
ओके ओके, ठीक है, तो सही है. थोड़ी और मेहनत कर लो और रिवाइज कर लो.
26 नहीं 16 नवंबर 16.
अच्छा 16 है, ठीक है, कोई नहीं, तब भी टाइम है. रिवाइज कर लो और स्ट्रक्चर पार्ट को और स्ट्रॉन्ग कर लो बिकॉज वो आपका स्पेशलाइजेशन है, उसमें तो आपसे पूछेंगे. एंड व्हेन आई एम सेइंग स्ट्रक्चर, तो स्ट्रेंथ ऑफ मटेरियल्स इंक्लूडेड. दिस डिफ्लेक्शन इज आल्सो, deflection portion is also very very important. Okay.
Yes, sir. Yes.
So all the best from my side. And now over to you, Vikram sir. आप देख लीजिए.
Yes, hi Ratesh.
Yes, sir.
So how are you?
I am fine, sir.
Okay. So let me know about your M.Tech project. What you did?
In my M.Tech, I work on the project impact assessment of bracing, shear wall, and damper on RCC building structure under blast loading.
Just hold on. Bracing, shear wall,
and damper on RCC building structure under blast loading.
Okay. How will you define bracing?
Bracing is the member which is generally provided in any structure to resist in lateral force as like earthquake, wind load, and any can we say blast load.
What type of member is it?
Bracing is the type of generally axial member. I not clearly twist.
My question is clear to you? Ratesh,
Yes, sir.
my question is clear to you or not?
Which type of member in bracing?
What type of member bracing is it itself? Okay,
Axial
so
member, sir.
axial member. Okay, fine. And can you define how shear walls are different from normal RC wall that we have?
Yes, sir. In normal RCC wall, shear wall different from normal RCC wall. Yeah.
Normal RC wall.
RC wall.
How you define dampers and where practically we are using?
Defined damper is the mechanical device which displays energy, seismic energy, and reduce the deflection and on the building.
Okay, have you ever seen these damper devices?
No, sir. Practically, I not seen, but in the any research paper and in any video, I seen damper.
Okay, so from where you get this idea to do work on this bracing, shear wall, and dampers on RCC structures?
Sir, this idea I come from my M.Tech and I say design for building for blast loading. I see that in this building come many deflection and it fell in syndicate. Yeah? So we have two case say this member increase the cross section of building. Our other provide passive devices. So in this project, I provide passive devices like dressing server.
How will you define the blast loading?
Blast load is the very short duration pressure wave as like 5 to 10 milliseconds.
Okay, so what do you think we are designing for that one? On what basis you are designing the structure for the blast loading if it is just acting for the 5 to 10 milliseconds, what you said?
Yes, sir, it is 5 to 10 milliseconds. So we non-linear time history analysis this member for.
Can you tell me what is the difference between load bearing structure and frame structure?
Yes, sir. In load bearing structure, load is also transferred by wall. But in the frame structure, load is transferred by slab load is come on beam and beam load is transferred by column and got in the footing and so on.
Can you tell me which one code we are using for the construction of this RCC work?
RCC wall.
RCC work.
IS 456 2000.
What is this 2000?
2000 means this code is revised in 2000 latest.
Right now 2022. Any amendment?
No idea.
Which one code is for the plain cement concrete work?
Plain cement concrete. No idea.
Okay, how load is being transferred from slab to beam as per IS code?
Slab to beam, sir, it depends on geometry of a slab. As like a slab is rectangular, then triangular load is transfer all side. If a slab is a rectangular side, Then on the shorter side, comes triangular load transfer, and longer side, trapezoidal load transfer.
Okay, fine. Can you tell me what is the difference between bending moment at a point and moment at a point? Both are same or they are different? What do you think?
Sir, ये different है, sir. Means any point moment we apply moment, then moment is moment at this point, and bending moment is the sum of all the moment by any lateral force and moment at the any one side of the section. Means we
And,
can.
yes, go ahead. Go ahead, Ritesh.
Yes, sir.
What you are saying, please proceed.
Yes, sir. It is difference between
Footing and column junction that we have. RCC footing, RCC column. What type of joint that we have?
RCC column and RCC footing. Joint generally fixed joint.
Okay, good, fine. What is the difference between point of contraflexor and point of inflection?
Yes, sir. If bending moment is change sign, this point is called the point of contraflexion. But deflected edge of any building change sign is called the point of inflection.
Okay. So if we want a maximum value of this bending moment, so where we will get the maximum value of bending moment?
We find the maximum value of bending moment when shear force change sign, shear force
sign.
0, shear force 0.
Meaning to say that whenever shear force 0, it means bending moment is maximum. Is it okay?
No, I not want to say.
Then correct it.
No, sir, no, correct.
Okay, suppose we have a beam and more than 1 0 shear point we have. So what do you think?
Yes,
at every point we will have the maximum bending moment?
No, sir, no.
Okay, fine. So I think Ritesh, right now we can provide feedback to you. Yes, over to you, Tyagi sir. Or let me provide the feedback first. So Ritesh, what I ask you, bracing, just have a look. Although you just have idea. So having kind of the force along its axis, axial member we have. It might be a tie member, it might be a strut.
Yes, sir.
Okay. So how shear walls are different from the normal RC walls? Have a look on this.
Yes, sir.
Okay. And dampers that you are saying in buildings we are providing, just go with the in bridges also. No? We have this what we call the bearings.
Yes, sir.
These are also acting as a seismic stoppers that we have, or dampers,
yes,
practically. Okay. And where you are getting the idea and what was role of your in this project, I think you have to little work on this one also. थोड़ा इसके ऊपर और work करो.
Yes, sir.
बहुत अच्छा आपने आंसर नहीं दिया है रितेश.
Yes, sir.
और जब आंसर करो, when you are delivering the answer, so
yes,
I think you looks nervous. So just keep little smile on your face. Just enjoy
yes,
the
sir.
session.
Yes, sir.
Okay. And what I ask you, like load bearing and a frame, that was okay. IS 456.
Yes,
this is
sir.
for both plain cement, concrete, and reinforced.
Yes, sir. I think, but I got little confusion. So
now see what will be the impression of you on the particular interviewer who's asking that question. You're going for this PhD program.
Yes,
and
sir.
IS 456, you said 2000. Just add, sir, there is amendment in 2013.
Yes,
amendment 4 is there.
Yes, sir.
Okay, recent amendment you can check.
Yes, sir.
What was the changes? Just have a little look on that one. They will not ask any brief regarding that one.
Yes, sir.
And point of contraflexor, point of inflection. Okay, that was again fine. So what I ask you, bending moment, we want the maximum value of bending moment. So just listen carefully. At the point of maximum bending moment, shear force must be 0.
Yes, sir.
We are not saying at the point where shear force is 0, bending moment is maximum. No, we are not saying that one.
Yes, sir. Yes.
Might be possibilities there for a particular beam, the loading condition is such that we are getting more than 1 0 shear force point. So what it
Yes.
mean, at every point we have the maximum value of bending moment? No, big no. At the
Mhm.
point of maximum bending moment, of course the shear force must be 0 in the SFD.
Yes,
So you must heard about these two equations. Rate of change of shear along the span is nothing but shear force.
yes, sir.
That is a lifeline of the strength of material, two equation that we have. Dm upon dx equal to shear force B,
Yes, sir.
and dv upon dx is nothing but rate of loading.
Yes, sir.
Okay. So overall, okay, so not big flaws. Anything else from technical you want to ask?
Sir, how RC wall and RCT and shear wall different from this, sir?
So actually what you did in your project, that was the question. What you did on the shear walls. And RC wall, you can just compare it with this ERS structure also.
Yes,
Earth
sir.
retaining structure. We have the retaining wall. No? So
Yes,
that is
sir.
also RC wall that we have.
Yes, sir.
So that's why I ask first from where you get idea to do this project, because bracing is there, shear wall is there, dampers are there.
Yes, sir.
Collectively, there are the large things that you consider.
Yes,
Bracing, we
sir.
have the separate design for the bracing or lacing, what you call.
Yes,
And
sir.
shear wall is the separate design that we have.
Yes, sir.
Dampers are totally separate.
Yes, sir.
Just see, if you're not finding the answer, then I will tell you. Just first
Yes,
of all,
sir.
work, or you can
Yes, sir.
share your thesis work with me, so I can
Yes, sir.
give you a better explanation of this.
Yes, sir.
Okay. Yes, Tyagi sir, over to you. Anything else, Ritesh?
रतेश,
Yes, sir.
अभी कहाँ पे है तुम्हारा इंटरव्यू है?
IIT हैदराबाद, सर.
ओके, तो चलो इंग्लिश लैंग्वेज तो वहां बोलना पड़ेगा थोड़ा तुम्हें इंग्लिश में.
Yes, sir.
थोड़ा मैथमेटिक्स से क्वेश्चन पूछेंगे, तो मैथ में आपने सेटिस्फैक्टरी रेस्पॉन्स नहीं दिया यहाँ पे.
Okay, sir.
ठीक है, तो मैथमेटिक्स में डिफरेंशियल इक्वेशन, लीनियर अलजेब्रा, ग्राफ, ये सेक्शन को पढ़ना पड़ेगा ना.
Yes, sir.
देखो रैंक मैंने इस क्वेश्चन में पूछा, आपको दिख रहा है?
Yes, sir.
ये क्या है? 4 रोज है और 2 कॉलम्स है, तो 4/2 का मैट्रिक्स है.
Yes, sir.
अब इसकी जो रैंक है वो इस मिनिमम नंबर जो है 4 और 2 में 2 है.
Yes, sir.
रैंक इसकी 2 से लेस रहेगी या ठीक है,
Yes, sir.
इक्वल हो सकती है.
Yes, sir.
अब अगर 2 है या 1 है, ये 2 पॉसिबिलिटी है.
Yes,
तो यहाँ
sir.
पे 2 कॉलम बन रही है.
Yes, sir.
अगर ये एक दूसरे के मल्टीपल होते तो रैंक 1 हो जाती.
Yes, sir.
ये एक दूसरे के मल्टीपल नहीं है,
Yes, sir.
बिकॉज ये 3 टाइम्स है, लेकिन ये 3 टाइम्स नहीं है ना.
नहीं, sir.
तो ये मल्टीपल नहीं है, तो इसका मतलब 2 लीनियरली इंडिपेंडेंट कॉलम्स हैं इसमें.
Yes, sir.
तो इसकी रैंक 2 है.
Yes, sir.
और ये जो डिफरेंशियल इक्वेशन यहाँ पे देखो, इसको
Yes,
d
sir.
ऑफ xy लिख सकते हैं ना,
Yes, sir.
और इक्वल टू 0.
Yes, sir.
ये डिफरेंशियल ऑफ xy तो है ना, ये लेफ्ट साइड.
Yes, sir.
तो इसका मतलब xy इक्वल टू कांस्टेंट. तो ये किसकी फैमिली है? हाइपरबोला की फैमिली है.
रेक्टेंगुलर हाइपरबोला.
हाँ, तो आप सर्किल बोल रहे हो.
Okay.
तो थोड़ा सा ग्राफ्स, डिफरेंशियल इक्वेशंस, लीनियर अलजेब्रा, ठीक है, इन चीजों को रिवाइज कर लो एक बार.
Yes, sir.
3 चैप्टर मोस्ट इंपोर्टेंट रहेंगे तुम्हारे लिए.
Yes, sir.
एक तो सारे ग्राफ,
Yes, sir.
और दूसरा ये आपका डिफरेंशियल इक्वेशंस
Yes, sir.
और मैट्रिक्स.
Yes, sir.
इनको रिवाइज करो सारा. चलो, ओके, फिर ऑल द बेस्ट.
Thank you, sir.